Schrödinger was a great communicator. At the Institute, you hear a lot of stories about them. Well, in many parts of Dublin, you hear lots of stories. When you have been in the long room of Trinity, you know that this includes the stage of the Abbey Theatre. So it's quite easy to imagine to communicate with him. And I think it's quite useful. And of course, there is a living tradition which you feel, for example, in the essays which the organizers of this meeting, Mike Murray, Luke O'Neill, Keela Farrelly, Thomas Ryan wrote in a little booklet. They're very well worth reading. Of course, I mentioned that also because I want to disagree with half a sentence written by Luke. And so let me make one suggestion at the end of this meeting to the students. Put Schrödinger's What is Life on half of your screen, page by page. Read it very slowly. Use the other half of the screen to get information about the things you have forgotten or never learned. And go through it. Pay, of course, notice to the great ideas, which I won't say anything about because they have been discussed extensively during this fascinating 2 days. Take note of the blunders. Let me just mention one of them. He talked about 48 human chromosomes. Well, probably as a student at that time, you would have failed if you would have given a different number. But of course, Schrödinger might as well have just looked at the photographs around, enumerated the chromosomes, and found that the number, which most people believed of that time, was wrong. So it certainly was a kind of blunder not to do that. But the most interesting thing, and which you could use to reflect on your own research, were the big new ideas he got very close to without making the final steps. And that's always what happens if you move in the dark. It certainly happened a number of times to me, that much later you recognize you were just a few steps away from something which would have been very nice, but you missed it. So when you read Schrödinger's book, he talks about chromosome, and one of the first things he said, well, probably it's not all of the chromosome which is so important. There probably is some axial fiber in the middle which does the essential stuff. Or the way he talks about information. He has been criticized for not really understanding information in the Shannon sense, but of course he calculates it. But as a concept, he subsumes it's to order, as you also have heard in many talks. Now, order is too imprecise to describe what he's doing. But the only thing which was missing was a word, a new word, or a new meaning of an old word coined to describe this particular meaning. Now, Schrödinger, in principle, was good at coining new words. And everyone who today works on quantum computation, which perhaps one day will be the main legacy of what many people, but also Schrödinger, have done, he coined the concept of entanglement. He didn't define it very precisely. Certainly, in contrast to information, when he talked about the Morse code, he calculated the information. But for entanglement, he didn't give a formula, but he might have done it. So that's one thing. And once you have worked your way through the book, imagine sitting with Schrödinger in the lectures. So do the reading before you forget the lectures. And imagine talking to him afterwards. Now, some lectures Schrödinger just would have been exhilarated about. In his book, he talked about finding some genetic information. Looks very much the same, independent of which species is it, but if you could read it, the way he phrased it, it could be a rhododendron or it could be a woman. Now, I hope he wasn't talking about a single chromosome from which you couldn't read off the sex, but I imagine he was thinking about a whole cell. And Schrödinger just would be fascinated after Svante Pääbo's talk that this is now a working program of molecular archaeology, just finding genetic information from past times. And I hope that somewhere in the world, archaeologists sit together and talk about the possibility of creating some institute for molecular archaeology. That certainly should be one legacy of what happened due to Schrödinger and after Schrödinger's time. And so, what other legacies apart from quantum computation, apart from his ideas? What about the other thing he would be fascinated about? I think it's in the book he wrote that he didn't know if it would be possible to make progress. The last talk and other talks we had before was about consciousness. I think he would be much more optimistic now that consciousness can be understood. When John O'Keefe in one of the first lectures talked about it, after I asked him, and he said, well, he's quite confident that when he has some part of the cortex participating in the conscious experience of the moment, he would be able to recognize it. So you probably could not put consciousness or the conscious part of the brain in a three-dimensional diagram, but Schrödinger wouldn't have cared. In the Schrödinger equation, when you have a many-body system, then you would describe it by a wave function in a much higher dimensional space. And so, well, take the Cartesian product of several cortices and have some fiber bundle over it, and then in that, according to what John O'Keefe says, you could localize consciousness. And when you can localize something, then I'm confident that eventually it can be understood, though people would have different opinions how fast this day will come. Well, another thing Schrödinger would have very much liked is that, well, the other part of his book, Thermodynamics, when you look at the fascinating movies you could see during these 2 days, there was at least a little bit of Brownian motion in it. Just a very random environment, not realistic, of course, otherwise it would be very difficult to make sense out of the movies. But certainly this is something one has to think about. Schrödinger was fascinated by the stability of biological information in development, in inheritance. And of course, part of this stability is due to quantum mechanics, as he explains in great detail in his lectures. But there is more to it. When you look all these very complicated regulatory system, let's say blood coagulation, or many examples, the patterning, segmental patterning of insects during development, they are described by, you could describe them by differential equations. And at least in one case, it has been shown that the equation which comes out has an incredible degree of stability in the outcome. You can use input which differs by orders of magnitude, and the output is the same. That's a new mathematical phenomenon, which, as far as I know, has not yet been studied by mathematicians. It has been invented by nature after a lot of trial and error. So for other talks, about the politics. Schrödinger, of course, in 1943 was very much constrained with political remarks, but he certainly, in What is Life, he reflected on the genetic consequences of the slaughter of the young generation in the wars, which recalls Trump's remark on McCain, I like people who don't get caught, which looks like a remark on Darwinian selection. Maybe not the best possible one. But certainly there are other dangers going on. And when you remember the talk by Beth Shapiro, how difficult it is to save just three species she talked about. And you now see that millions of species are in danger. Then, well, maybe Emma Teeling is right that you need a moonshot problem to save the information around. But it's not so easy. In his introductory remark, Luke O'Neill mentioned that the Irish saved civilization. In a way, they did it. They certainly saved correct Latin, which was getting lost even in Italy. And of course, they wrote down a lot of important things in poetry, and the oldest High German texts around are translations from the Irish language. But nevertheless, at the end of antiquity, many very important books were lost, and every historian will be able to enumerate many of them. Well, the Irish certainly would have copied them if they had been told which really were the important books at the time. And at the time, it would have been very difficult to recognize it. So certainly, well, 30 years ago, I was very optimistic about saving the species. But 30 years on, CO2 concentrations in the atmosphere continue to rise linearly. And before it turns over, I will think about upper bounds on the effects of the ecosystem as wishful thinking. When it really starts to turn over, it will continue to rise, but less at a smaller rate, then one can believe that one can give an upper limit. Well, let me finish with a one thing which I disagree with, but Luke remarked that Schrödinger thought that based on Delbrück's experiences with X-rays, that the size of a gene was about 1,000 atoms. Now, that would be a contradiction because earlier in the book he does a different estimate. He takes the size of the chromosome, he divides it by the number of genes discovered at the time, and he derives an upper bound on the size of a gene of about 1 million atoms. Not so wrong. Of course, even the concept of junk DNA, wrong as it is, was inconceivable at the time. So what the 1,000 atoms which comes later, this is the part of the gene which was influenced by one mutation event. So it's more or less, it's closer to what is a base pair. So when you would have asked him at the time, think about a conversation with him, when he thinks about a gene in a Morse code way, as made up by many elements, how many elements should it be? Well, he probably would have said, well, something like 1 million divided by 1,000, which is not so wrong after all. So having conversations with Schrödinger, here in Dublin, maybe it's a little bit more than an intentional object or so. Because of the tradition and around, there are people in the audience who have met Schrödinger. He has given lectures in Trinity at a space which still is used. So in a way, he is very present. And during these 2 days, we all have felt the influence of that. Without his work, this splendid conference would not have been possible. But of course, it has to be kept alive by you. And let's thank Trinity for keeping this tradition alive, keeping this spirit alive, the spirit for inquiry into the unknown, the spirit of discovery. So, thanks for visiting.